Welcome. In this screencast, we take a look at a couple of algorithms that people use for multiplication. The standard algorithm that you're very familiar with, we're going to connect it to the area model. And then we're going to take a look at lattice multiplication, which is familiar to some students, but not to all students for reasons I don't fully understand. So let's do something really basic. Let's take a look at 17 times 12. And we all know how this goes, right? We multiply 7 times 2, that's 14, but the place values are the ones place and the tens place. So 7 times 2 is 14. 14 is 1 10 and 4 ones, right? And then the 2 times 1, that's 2 times 1 10, so that's 20, plus another 10, that's 30, that's 3 tens, we put a 3 right there. And then we multiply the 1 by the, right? We know what comes next. We do this 1 times the 7, and we write a 7 down here. Why do we write the 7 over here? Well, because this 1 isn't a 1. This 1 is in the tens place. So this is a 10 times 7. And 10 times 7, that's 70. And 70 is 7 tens. We have to write that in the tens place. And then 1 times 1 is 1, and we write that over here. Why do we write that over here? Because this is 110, and this is 110, and 10 times 10 is 100, and the hundreds place is over here. So we've got to put the 1 where it belongs, in the hundreds place. And then we add. We got the 4 ones, 3 tens, and 7 tens is 10 tens. 10 tens is 100 and leaves no tens behind. And then you have 2 hundreds and you're done. Well, why do we do that? Why do we play this game where we multiply everybody by everybody else and we add just right? Like, why does that even make sense? Well, if I may, 17 times 12 is 17 rows of 12, right? It's 17 rows of 12. Now, I don't do well with 17. I do much better with 10 and 7, and I don't do well with 12. I do much better with 10 and 2. And, and so the area of the whole rectangle is the sum of the areas of the individual rectangles. Do you see where all of these are down there? Do you see where they are? Do you see where the 100 is, where the 70 is, where the 14 is, where the 20 is? Because if you can see how this works, you can see how this works. It is very doable from there. Try it. Try it in the privacy of your own home. Try multiplying. Oh, that wasn't right. Live television. Try 19 times 26. Take a look at it as 19 rows of 26. 19 rows of 26, where I don't really know how this goes, but I know that I can break that up into a 10 and a 9, and I know that I can break this up into a 20 and a 6. And so we can find the areas of the individual pieces. 9 times 6 is 54. 54 is 4 ones and 5 tens. 6 times 1, that's 6, but it's really 60. And 5 more is 110. 2 times 9 is 18. And then 2 times 1 is 2 plus 1 is 3. And so maybe that's it, maybe? Can you see where all of these pieces are over here? The other method that sometimes is helpful is the process called lattice multiplication. And in lattice multiplication, let's pretend we want to multiply 87 by 24. The way the lattice works out, it's a 2-digit times a, oh, that's just hideous. Here we go. I have a master's degree. Can you believe that? It's a 2-digit times a 2-digit. So we set up a 2 by 2 square, 87 times 24. And then we draw these diagonal lines, and those diagonal lines actually help us with place value. And then all we have to do to know lattice multiplication is know single digits times single digits. 8 times 2, that's 16. 7 times 2, that's 14. 8 times 4, that's 32. 7 times 4, that's 28. And then when we want the answer, we add down the diagonals, starting at the bottom. That's 8. Run through those, that's 8. Run through those, that's 10. Can't write a 10, so we write the 0 and carry. That's 2. 87 times 24 is 2088. It is for the viewer to consider why these diagonals separate place values the way I think they do. How do we know that this is going to be the only digit in the ones place? How do we know that all of these contribute to the tens place? How do we know that all of these contribute to the hundreds place? How do we know that all of those contribute to the thousands place? That's something to consider seriously so that it doesn't just become a magical process that works because it works. Okay, hopefully this is helpful to you. Looking forward to seeing you in class.